Another example 3, and this time we're trying to evaluate the integral of dx over square root of 9 plus x squared. Again, by looking at the term in the denominator, we have square root. It looks more in the form a squared plus x squared. Therefore, we have to use the substitution x equal a tangent of theta. And theta is between negative pi over 2 and pi over 2. So it's in the first and fourth quadrant. Now, square root of 9 plus x squared is equal to square root of 3 squared plus x squared. So my a happens to be 3. Therefore, x is going to be 3 tangent theta. And my theta is between negative pi over 2 and pi over 2. If we take the derivative of x, then dx will be equal to 3. Derivative of tangent is secant squared theta d theta. And now we have to do square root of 9 plus x squared, which is equal to square root 9 plus x is 3 tangent theta, so if you square it, you get 3 tangent theta squared, which is square root of 9 plus 9 tangent squared theta. Now we factor the 9. 1 plus tangent squared theta, which is equal 1 plus tangent squared is secant squared, so secant squared theta, which is equal to 3 absolute value of secant theta. Now this is just equal, absolute value of secant theta is equal secant theta, because secant theta is positive from negative pi over 2 to pi over 2. Secant theta is positive in the first quadrant, secant theta is positive in the fourth quadrant. Now let's evaluate the integral of dx over 9 plus x squared square root is equal integral of dx is right here. So it's 3 secant squared theta d theta. Square root of 9 plus x squared is right here, which is 3 secant theta. Now simplify 3 with the 3 and secant with secant. This is going to be equal integral of secant theta d theta, which is equal one of those integrals you need to memorize, which is equal to ln of absolute value of secant theta plus tangent theta plus some constant c. We need to return to the original variable x. This is can be done by drawing the triangle, the right triangle. Now since x is equal 3 tangent theta, now this means that tangent theta is equal x over 3, so let's assume this is theta, so the opposite side will be x and this will be 3, and let's call the hypotenuse c. Let's see what this equal to. Using Pythagorean theorem, x squared plus 3 squared is equal c squared. So c squared is equal x squared plus 9. So c is equal square root of x squared plus 9. So this is square root of x squared plus 9. Now this is equal to ln of secant theta is equal to hypotenuse, which is square root of x squared plus 9 over 3 plus tangent is x over 3, everything plus some constant c. We can use the log properties, and this is equal ln of the top. The numerator is x squared plus 9 square root plus x minus ln of absolute value of 3, which is 3, plus some c. If we call this a constant c1, this will be equal ln of x squared plus 9 square root plus, don't forget the 3 here, plus x over 3. Oh, no, we don't need that. Plus x plus some constant c1. So this is the answer. And we're done about this example.